Hello and welcome to our video solution for problem 11, our final problem from Superquiz 3. And in this problem we're asked to compute a line integral of a vector field. And the vector field is, well, fairly complicated looking. But what we're going to be using is Green's theorem, which is going to allow us to simplify the calculation quite a bit at the cost of replacing the line integral with a double integral. So Green's theorem is going to tell us that this line integral is going to be the same thing as the double integral over the inside of this curve. Okay, so this is a closed curve because it's a circle. Okay, so we used as our notation this del inverse c to denote the inside, which in 2D it makes a lot of sense to do that. And then we replace the vector field, since we're going to switch to a double integral, so we should have a scalar function. We're actually going to replace it with the two-dimensional curl. And the 2D curl is actually just a scalar function, and we'll write that down in a moment. And then we have dA. So we'll recall that the curl of a two-dimensional vector field where, well, let's say we write the vector field in components as p comma q, then the 2D curl is the partial derivative with respect to x of q minus the partial derivative with respect to y of p. So in our case, the first component is our p, the second component is our q. Those look fairly complicated, but hopefully this curl isn't going to be too bad. So let's see. If I take the partial derivative of q with respect to x, you'll notice the first part is 8x. That's pretty easy. You get an 8. And then the rest of this, my goodness, they're all y's. I take a partial with respect to x, and those are all 0. Hey, that's fantastic. Okay, I don't even need parentheses here. Okay, so then we're going to subtract the partial derivative of the p component with respect to y. So let's see here, x to the 7, x, oh my goodness, they're all x's. The only thing I have left here is a 9y. So the partial of 9y with respect to y is just a 9. So the curl, amazingly, is just -1. Wow, that's really wonderful, because that means I'm essentially just going to be computing a double integral of the constant function 1. I can pull the negative outside. So we can rewrite this as negative the double integral dA, which just means we're asking for the negative of the area of this region inside C. Okay, well, it doesn't really matter where the center is then. We just care that you have a circle of radius 5. We know that the area of a circle with radius 5 is going to be 5 squared times pi. So 5 squared times pi. This is just the area of a circle with radius 5. Okay, and so our answer is going to be -25 times pi. Yeah, that really does simplify the calculation. I don't think I'd want to do this line integral using the original vector field here.